Hello all, welcome to the very interesting lecture. So in the last lecture, we have understood about the role of AI, the other classifications of AI and other things, right? And I have actually taken one of these snapshots so that these are the golden rule that we will be following it throughout the lecture, right? So these are the golden rule that we will be following in this lecture also. So let's start with the supervised learning. Okay, so what we will be studying in the today's lecture, we are supposed to take one data and then we are supposed to train one supervised model, okay, in order to take the solution of our problem, okay, from the model, right? So we will be following entirely this golden rule. Okay, so let's understand, right? So first of all, let's go to the number one step. What is raw data? Okay, so we have taken one raw data. Let me show you the data first. Okay, at the very first glance you would not able to pick up the data, but let me show you. Okay, so let's say that these are the data. Okay, these are the data of a hospital. Okay, accessed hospital database where it contains all the patient's information, okay, related to their pregnancy details, their blood glucose level, their blood pressures, their skin thickness, their insulin, their BMI, and their age category. And out of all these data, we need to make a predictive model, okay, so that it could able to give the blood glucose level. Okay, it could able to predict the blood glucose level. So again, let's come back to our first step, which is like we have this raw data. Okay, and what is our problem statement? Our problem statement is that you are a AI engineer working with the hospital patients database. The goal is to build a predictive model using a patient health measurement to help doctors make decision faster. Okay, the dataset contains the basic health record from 300 patients, and these are the features collected during the health routine checkup. Okay, every patient go week or months, right, for their health routine checkup, right? So hospital have collected their data set and we have seen the data set, right? How does data set looks like? Now let's look the two version of the problem. Okay, the first is like the regression problem and a classification problem. Again, so we have done the first step. Now the second step is we need to decide that what is our problem statement. We know our problem statement. Now we need to decide that whether our problem statement is regression problem or a classification problem. Okay, so let's look into the regression problem for now. Okay, so in regression problem, our problem title is we need to predict the patient blood glucose level. Okay, we need to predict the patient blood glucose level. So we have selected our problem statement, right? Now after selecting our problem statement, now what is the next step? Next step is to perform the EDA, which means the exploratory data analysis, right? I have told you in the last lecture also. What is exploratory data analysis? Where this, so see, the point is the data which I have already showed you, right? So this is very raw and dirty data. Okay, as you can see that this contains some of those column which is like unmatched. Okay, and some of those columns are not even like filled up. Okay, maybe someone has done some mistakes, right, by filling up the data sheets, right? So this is very raw data. That is why for this problem we need to do the ED operation, okay, which means the exploratory data analysis. Okay, we need to apply some statistics, very little of statistics, some feature engineering, some data cleaning, so that we can clean our data sets. Okay, so in order to perform this, these are the like libraries, okay, or a tool, okay, enabled by the Python. Okay, so we are supposed to use the NumPy, the Pandas, the scikit-learn. So this is the scikit-learn. Okay, this is one of the most popular library in the machine learning, right? We will see everything. So let's perform the EDA. Okay, we are supposed to perform the EDA. We are going to draw some visualization, some graph, so that once we clean our data sets, right, once we clean our data sets will be present in this .csv file like a normal Excel file, right? So that we are supposed to save it into our local storage. Okay, so done. Now let's say that we have the raw data, right? We have done the problem. Okay, we have gone through the problem which were given to us by any of our client, right? Then we have decided that whether it is a regression problem or a classification problem. Then we perform the exploratory data analysis, like some basic stats by using the tools given by these Python's library, right? So after that we have done the feature engineering, we have done the data cleaning part, and then we have saved our data set into our local storage. Got it? Now we need to choose the supervised model. Okay, so we need to choose the supervised model. Why? Because we are learning from the very first phase. So we are learning about the supervised model. Okay, and these are the machine learning model that we have already like scripted in the last lecture, right? So these are the supervised machine learning model. The first step is linear regression, the logistics and other things. Okay, these are the supervised machine learning model. These are the libraries, okay, or a tool which we are supposed to train our model by feeding this supervised data, okay, the raw data which I have already showed you, right? So we will be feeding this raw data by taking the first linear regression model, okay, to train our machine so that it could able to predict that whether the patient has, let's say, like what is the glucose level of the patient. Okay, I hope you get it, right? So now moving to the next step, so we have actually selected that one of our supervised model, okay, which is linear regression, right? So we have choose the linear regression model, okay, the first machine learning model, right? Then after that, what we are supposed to do? So see, we have done the library choosing part, right? We have done hands-on experiment, right? Now let's understand about this model logic, okay, that what is like model logic part. Okay, so we have done choosing our supervised model, right? Now let's understand about that why we have chosen this linear regression model. Okay, so in order to understand the linear regression model, let's understand in very simplistic term. So let's say that you need to predict the patient glucose level, correct? And you have other data like the patient BMI measurement, the patient insulin, the patient weight, the patient age, right? Based on these, let's say that you have like crafted all these things into a 2D diagram. Okay, I will show you in the implementation part that how you will make a graph, but for now just understand that for each patient you have their glucose data and you have other data. Okay, and let's say for all the 300 patient you have plotted all these things into a 2D graph. Okay, and the graph looks like this. Can you observe one thing? Can you observe that there is one linear trend? Okay, there is a linear trend. So the reason, because it is showing a linear trend, the reason that why I have selected the linear regression model, okay, so that I can basically fix my single line, so that one single line itself able to catch up my prediction part. Simple. Okay, so let's say that this is, there are so many lines, right? So let's construct a hypothesis. Okay, hypothesis means what? The assumption, simple assumption. What I will do, because I have this linear trend right now, what I will do is that I will just try to draw more than one, like more than one line, okay, just to check that which line fits well on this data. Okay, so I have done it experimentally where like I have chosen, so for all the 300 data points I have chosen, let's say, 5 lines. Okay, this is my line 1, line 2, line 3, line 4, line 5. Now let me ask you one question. Which line do you think is like the best fit? Simple, just answer it, right? Do you think that L5 is the best fit? Of course not, because it is not like it is going in some other direction. Okay, it is not in a, it is not in a, it is not like condition, it is not like in the range of in the range of data. Okay, it is going in some other direction, right? Now let's look line number 1. Line number 1 is also not like, it is going outside of the boundary. Okay, so I would simply reject line number 1 and line number 5, right? Then what is about line number 4? Nah, line number 4 is also very bad, right? Because it is not also touching all the points, right? So I may have, so I come up to the conclusion that maybe line number 2 and line number 3 is my best fit, right? How do I come up with a conclusion? By watching the, by watching the diagram itself, right? Now the same thing I am expecting my linear regression model, so that my model itself is going to give me the best possible line. I don't need to do it anything. Okay, that is why it is like, that is why I have chosen the linear regression model. Why? Number one step is that it has showing the linear trend. Okay, the number second step is that I will choose my linear regression model so that it will going to give me the best possible suited line, so that in future whosoever patient I have, right, I will just try to put their data and I will see that whether like, I will see whether it is like near to my predicted line. Okay, and if it is, then I will take the point from that line itself in order to predict the next data. Simple, right? Similarly, again, so this is the line, okay, and these are the slope. So in mathematics, the line has two things like the slope and intercept, right? You don't need to understand this thing, just understand that whether this, so for all this line, these are the different slopes. Okay, so I am asking machine, okay, I am asking machine that which is the best slope, or simple, which is the best line which is fitting this data representation, this linear data representation. Okay, and suppose that my machine has given the best line. Okay, so let's say I have imported my linear regression model. Okay, so I have up to this part. Okay, this is my model logic. I have explained you my model logic, right? Now I am supposed to import my model from scikit-learn. Okay, scikit-learn is a tool where all these models are present, right? So I will be importing all this model from the scikit-learn, and I am going to fit my data. Okay, I am going to fit my data. See, I will again go to that diagram, right? See this part, right? So I have chosen one linear regression model from scikit-learn. Okay, so this is my scikit-learn. I have chosen this linear regression model. I am going to train my data, like I am going to train my linear regression model by feeding my raw data, by feeding my raw hospital data. Okay, so that it is supposed to give me the best line possible. Simple, right? So again, going back to the moving forward, right? So suppose that I have got the best line. Okay, suppose I have got the best line. So this is, let's say, my best line possible. Okay, which is like my model. The line itself is my model. Simple, understand this thing. Okay, the line itself my model, so that in future whatever patient data I have, I can just try to put it here and see that what is the outcome of this line. Okay, and what is this axis? So this is basically my glucose. Okay, so from line itself I would able to predict that what is the next patient glucose level. Simple, right? So suppose if I get the, what does machine learning do is that it chooses the best fit. Okay, now the most important thing, right? So let's say that machine gives you the best line possible. Now how would you know that this is the best line? Okay, there has to be someone who is like correcting everything, right? Who's trying to judge everything, right? So in order to judge my machine's best line, there is something called as loss function, right? What is loss function? So loss function is basically tells you that how much loss you have. Okay, or let's say how much magnitude of loss this learned machine have. Okay, the machine which have already learned it, right, from your like data which you have already fed in the previous step, right? So what is the correcting term? Okay, how good is this machine? Okay, how will you actually understand these things? Okay, how will you actually measure these things? So in order to measure these things, you need to use the loss function. Okay, so loss function is basically tells you about how good your machine is. Simple. Okay, now after like judging your machine, okay, after judging everything by this matrices, okay, I will tell you in the implementation part as well. So there is three things. Okay, there is a mean squared error, there is a mean absolute error, there is a r squared value. Okay, so these are the loss functions. Simple. Okay, so okay, so we have explained about the model logic. Okay, we have imported this model from the scikit-learn. Okay, now what we are supposed to do is that after training the model, right? So once we train our model, right? So once we train our model, we need to do this train test split. Okay, what is train test split? It means that whatever the data I have, I want to split my data into train, test, and validation. Okay, train data will go into my linear regression model. The model will learn itself and try to give the best model. Okay, and whatever the model that it has given us, right, I am supposed to test that model by using the test data, the unseen data. Simple. Okay, which I have not given it to the model. Okay, and in order to test it on my model, okay, in order to verify it that how good it is, I am supposed to use this loss function. Simple. Okay, then once I do all this step, then what I will do is that I am going to save my model and then the end. Okay, my entire linear regression pipeline is over. Okay, again let me walk you through from the step number one so that you can actually get it. So what was the problem statement? So these are all the patient's data, right? And these are the problem statements. Okay, we need to we need to predict the blood glucose level of the patient, right? So it is a regression problem. After selecting the problem, then we have done the EDA part, like the data cleaning part. Okay, after cleaning our data and saving it into the local storage, then we choose one of these models, right? One of these model, let's say linear regression model. Okay, we have chosen the linear regression model, fed the our supervised data in it. Okay, so that after choosing it, right, I have explained you that why I have chosen the linear regression model, because the data itself is showing me a linear trend. Okay, and I need to find out the best fit line means model, so that it can able to like understand the data much more in depth. Okay, so I have taken more than one assumption, like more than one line. Okay, line, or in machine learning term it calls hypothesis, simple. Okay, and I concluded that line number 2 and line number 3 are the best line. Okay, this I have concluded by visually see this, like by visually watching this data. Okay, all these things has been done by the machine. Okay, the machine learning model which has been imported by the scikit-learn. Okay, so this is the scikit-learn where I am actually importing my linear regression model. Okay, so that this model is going to give us the best fit line. Okay, this is my best fit line. Okay, this is my line which will help us to predict the next patient glucose level, simple. Okay, and after that, in order to test it, okay, in order to test it, there are some loss functions. Okay, these are the three loss functions on which we will be testing our trained model. Okay, simple. And after that, after training the model, if we satisfy, then we are going to save this model and then the end. Okay, so these are the entire pipeline I wanted to show you. Thank you. Let's move to the implementation part.